This video considers the calculation of the mean as the measure of central tendency for a set of data and of the variance as a measure of dispersion of the data. The mean is simply the average. The formula for the mean for a sample, which we will consider this little set of data, which represents the time that a physician spent with each of 12 patients, is given on page 174 as 6.1. And 6.1 says that x bar, the x with the line over it is typically called x bar, is equal to the sum of all the values of x. The minutes spent with each patient represents x, divided by the total number of patients, or n, which is 12. So here I'm going to put the sum of all of these values divided by n, the total number of observations. And the mean turns out to be 8.91 minutes. So I will label this x bar. Now I can also find the mean or the average with a function that Excel provides, equal average, which has already been introduced in an earlier chapter. And all I need to do is include all of the values of x, and I get the same result from the equal average function. Now we'll look at the measure of dispersion, in particular at the variance. The formula for the variance is given on page 176 in formula 6.3. What that formula says is that in order to calculate the variance, we need to take each value of x, that is the 2, the 8, the 11, and so on, subtract x bar, the 8.91, and square the result, and then add all those up. So here I will say that this is equal to x minus x bar, and that will be fixed with an F4 so that we will always refer to the cell B15 for x bar, and squared. So the first value that will be used to make up the variance is this 47.84. When I drag this down, I get all of the values that will be summed for the numerator of 6.3, and I will sum those here. So this will be equal sum of all these values. Now the sum of all those values must be divided to get the variance for a sample by not n, that is not 12, but n minus 1, which turns out to be 11. So I will do that here. This is equal to the sum of all of the squared differences between the actual minutes spent and the mean of all minutes spent divided by, and just to make it clear, 12 minus 1. So the variance, which is given here, is 12.0833. That value can also be found by using the Excel function equal VAR, which is the variance for a sample. And if I select the original values and hit enter, I get exactly the same result. One additional measure with regard to a sample is the standard deviation, which I will put here as STDEV, The standard deviation is the square root of the variance, so that the standard deviation is equal to SQRT using the XL function for square root of the variance, and it turns out to be 3.47. I can also get the same result by using the XL function equal STDEV and highlighting the original numbers. Again, I get 3.47. The difference between the variance and the standard deviation is that the variance, because it incorporates a squared value, is not on the same scale as the mean, but the standard deviation, as the square root of the variance, comes back to a scale which is comparable to the scale of the mean.